Meteorites have told Imperial researchers the likely far-flung origin of Earth's volatile chemicals, some of which form the building blocks of life. They found that around half the Earth's inventory of the volatile element zinc came from asteroids originating in the outer solar system, the part beyond the asteroid belt that includes the planets Jupiter, Saturn, and Uranus. This material is also expected to have supplied other important volatiles such as water. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. Volatiles are elements or compounds that change from solid or liquid state into vapor at relatively low temperatures. They include the 6 most common elements found in living organisms, as well as water. As such, the addition of this material will have been important for the emergence of life on Earth. Prior to this, researchers thought that most of Earth's volatiles came from asteroids that formed closer to the Earth. The findings reveal important clues about how Earth came to harbor the special conditions needed to sustain life. Senior author Professor Mark Recamper of Imperial College London's Department of Earth Science and Engineering said, "Our data show that about half of Earth's zinc inventory was delivered by material from the outer solar system beyond the orbit of Jupiter." Based on current models of early solar system development, this was completely unexpected. Previous research suggested that the Earth formed almost exclusively from inner solar system material, which researchers inferred was the predominant source of Earth's volatile chemicals. In contrast, the new findings suggest the outer solar system played a bigger role than previously thought. Professor Recamper added, "This contribution of outer solar system material played a vital role in establishing the Earth's inventory of volatile chemicals. It looks as though without the contribution of outer solar system material, the Earth would have a much lower amount of volatiles than we know it today, making it drier and potentially unable to nourish and sustain life." To carry out the study, the researchers examined 18 meteorites of varying origins, 11 from the inner solar system, known as non-carbonaceous meteorites, and 7 from the outer solar system, known as carbonaceous meteorites. For each meteorite, they measured the relative abundances of the 5 different forms, or isotopes, of zinc. They then compared each isotopic fingerprint with Earth samples to estimate how much each of these materials contributed to the Earth's zinc inventory. The results suggest that while the Earth only incorporated about 10% of its mass from carbonaceous bodies, this material supplied about half of Earth's zinc. The researchers say that material with a high concentration of zinc and other volatile constituents is also likely to be relatively abundant in water, giving clues about the origin of Earth's water. First author on the paper, Raisa Martins, PhD candidate at the Department of Earth Science and Engineering, said, "We've long known that some carbonaceous material was added to the Earth, but our findings suggest that this material played a key role in establishing our budget of volatile elements, some of which are essential for life to flourish." Next, the researchers will analyze rocks from Mars, which harbored water 4.1 to 3 billion years ago before drying up, and the Moon. Professor Recamper said, "The widely held theory is that the Moon formed when a huge asteroid smashed into an embryonic Earth about 4.5 billion years ago. Analyzing zinc isotopes in moon rocks will help us to test this hypothesis and determine whether the colliding asteroid played an important part in delivering volatiles, including water, to the Earth." When meteoroids enter Earth's atmosphere, or that of another planet, like Mars, at high speed and burn up, they're called meteors. This is also when we refer to them as shooting stars. Sometimes meteors can even appear brighter than Venus. That's when we call them fireballs. Scientists estimate that about 48.5 tons, 44,000 kilograms, of meteoritic material falls on Earth each day. What's that flash of light streaking across the sky? We call the objects that creates this brilliant effect by different names, depending on where it is. Meteoroids are what we call space rocks that range in size from dust grains to small asteroids. This term only applies when they're in space. Most are pieces of other, larger bodies that have been broken or blasted off. Some come from comets, others from asteroids, and some even come from the moon and other planets. Some meteoroids are rocky, while others are metallic or combinations of rock and metal. When a meteoroid survives its trip through the atmosphere and hits the ground, it's called a meteorite. Meteor showers. Several meteors per hour can usually be seen on any given night. When there are lots more meteors, you are watching a meteor shower. Some meteor showers occur annually or at regular intervals as the Earth passes through the trail of dusty debris left by a comet and, in a few cases, asteroids. Meteor showers are usually named after a star or constellation that is close to where the meteors appear to originate in the sky. Perhaps the most famous are the Perseids, which peak around August 12th every year. Every Perseid meteor is a tiny piece of the comet Swift-Tuttle, which swings by the Sun every 135 years. Other notable meteor showers include the Leonids, associated with Comet Tempel-Tuttle, the Aquariids and Orionids, linked to Comet Halley, and the Taurids, associated with Comet Encke. Most of this comet debris is between the size of a grain of sand and a pea and burns up in the atmosphere before reaching the ground. Sometimes, meteor dust is captured by high-altitude aircraft and analyzed in NASA laboratories. Finding meteorites. Most space rock smaller than a football field will break apart in Earth's atmosphere. Traveling at tens of thousands of miles per hour, the object disintegrates as pressure exceeds the strength of the object, resulting a bright flare. Typically less than 5% of the original object will ever make it down to the ground. These meteorites, pieces of meteors that are found, typically range between the size of a pebble and a fist. Don't expect to find meteorites after a meteor shower. Most meteor showers come from comets, whose material is quite fragile. Small comet fragments generally won't survive entry into our atmosphere. In theory, the Taurids and Geminids could send meteorites down to our surface every once in a while, but no remnants have been traced to them definitively. It can be difficult to distinguish a meteorite from an Earth rock by appearance alone in most parts of the world, but there are some special places where they're much easier to identify: deserts. In sandy deserts with large, open regions of sand and few rocks, dark meteorites stand out clearly. Similarly, meteorites can be much easier to spot in cold, icy deserts, such as the frozen plains of Antarctica. Why do we care about meteorites? Meteorites that fall to Earth represent some of the original, diverse materials that formed planets billions of years ago. By studying meteorites, we can learn about early conditions and processes in the solar system's history. These include the age and composition of different planetary building blocks, the temperatures achieved at the surfaces and interiors of asteroids, and the degree to which materials were shocked by impacts in the past. What do meteorites look like? Meteorites may resemble Earth rocks, but they usually have a burned exterior that can appear shiny. This fusion crust forms as the meteorite's outer surface melts while passing through the atmosphere. There are three major types of meteorites: the irons, the stonies, and the stony irons. Although the majority of meteorites that fall to Earth are stony, most of the meteorites discovered long after they fall are irons. Irons are heavier and easier to distinguish from Earth rocks than stony meteorites. How do we know where meteorites come from? Most meteorites found on Earth come from shattered asteroids, although some come from Mars or the Moon. In theory, small pieces of Mercury or Venus could have also reached Earth, but none have been conclusively identified.